Hello, everyone, and welcome again to another series of CPD in 43. Today is our August event of 2024. We have the Proctor Group, Buildings and Refurbishment Systems for Retrofit and Conservation. We have Adam here who's going to speak through that. And typically with our events, they will start off with the presentation, which he'll run through, and then we will have a Q&A session towards the end. Please do field any questions that you have into the chat box. We'll then pick those up towards the end. But without further ado, I'll hand it over to Adam and I'll disappear into the background. Thank you, Adam.
Thank you. Thank you very much. Hello, everyone. I'm just going to share the presentation. Yeah, perfect. So hopefully you can all see that. It should say the Proctor Group Learning Hub. Put a message in the chat if you're unable to see that, please. But yeah, I'm Adam Salt. I'm the Business Development Manager at the Proctor Group. I've been here for about 6 years now. The Proctor Group, we're kind of a family business. We work based up in Scotland, so UK heritage, and we look at the design in construction and kind of see where we can innovate that. So because of our kind of approach to the market, we have a lot of unique design solutions and benefiting your construction. And one of the big markets that we play in is the retrofit market. So today we're going to be looking at building refurbishment systems for retrofit and conservation. Now, this presentation is one of our CPDs that we're going to sort of power through today because I've only got half an hour. But if you're interested in having this presentation in more detail, please let us know. We're more than happy to come in and do it directly to your practice as well. So today we're going to be looking at sort of upgrading or refurbishing that sort of existing building, some of those common problems that can arise. Why is this important? Well, I think meeting the increasing demands for housing it's been challenging for some time. We've seen that kind of accelerated a little bit with the priorities and the circumstances brought by COVID as well. There's been a bit of a boom in the DIY sector during lockdown, so that's encouraged some even just redecorating of home offices and internal parts of the building. But then also combining that with housing, the increased emphasis on sustainability, recycling the existing building becomes an effective and attractive solution. I heard the other day that sort of come 2050, when we're looking to be net zero in England and Wales, 70 to 80% of that building stock is probably going to be today's building stock. So that tells me some of the greater gains we're going to have is by retrofitting our existing stock. And a lot of our buildings are very old, some listed, some just old solid wall constructions, going back to sort of the early 1900s and further beyond there. So doing that, upgrading these is going to be difficult. There's going to be a lot of challenges and we want to make sure we're doing it correctly, but the emphasis on how we do it as well. So today we're going to be looking at refurbishment aims and outcomes, different types of refurbishment projects, the framework and guidance that's out there to assist, the effectiveness of the assessments, a risk-based design in retrofit, and common scenarios and some solutions that we've come across on a lot of these projects. So let's dive into it. So there's three main categories we're going to be looking at: conservation and preservation, upgrades and improvements, and repurposing or change of use of the project. So we'll start off with conservation and preservation projects, especially those kind of listed or historical structures. They've got a number of limitations that may not present in other types of refurbishment. Even if retaining the actual period material is not required, the preservation of the essential character and any decorative features certainly is. So this is going to place some sort of limits on the extent of which we can increase that energy performance of our design. So that might be not being able to accommodate certain thicknesses of insulation, protect certain features. How do we reduce air leakage in an old solid wall construction? So plenty of challenges there for us to understand, establish, and to make a lot of these projects successful. It's going to require a lot of good constructive dialogue between your suppliers, of the materials, the building control, the architects, the designers, everyone working together to make sure we get a building that kind of works and is healthy. The next is where we're going to look at projects where the main focus is upgrade and improvements. So that's where we're solely focused on that performance requirement and getting the best out of our projects. So there's fewer conservation-based limitations on these. Some there might still be a consideration, but we want to try and get the best the best performances possible. There might be some limitations, especially around those windows and door openings, but there's usually on these types of projects a lot more freedom to accommodate sort of fabric insulation, service runs, and those other modern sort of requirements and technologies. I think the main sort of concern with these types of projects is making sure that there's consideration with cost, making sure it's effective, we're working within the budget. There's lots of great products and solutions out there, but it can get a bit out of hand within the design. So making sure we're value engineering as well to maintain within our budgets and still designing the correct fabric from there. And the last one is the category of changing its actual purpose of the building itself. So this could range from, say, a subdividing a large dwelling into flats and conservation of former industrial sites. So depending on the purpose of the building before and after each project, it's going to have its own kind of unique challenges. I think the main thing with these types of projects is try and get as much information about the existing building from the start. Especially we put emphasis on acoustics as well. It become very difficult to incorporate and budget for acoustics late on into the design if required, and it does seem to go a bit sort of missed within retrofit. But then there's the same with assessing the building from its thermal performance, its air tightness, how we're going to control the moisture with those upgrades, how it's going to work with the base current structure that we got and what we moved it towards. So getting that sort of relative baseline, understanding all that will help us then look at the improvements we're going to make. A structured and objective approach. So there are kind of three categories. Again, I've kind of gone through them very, very lightly. But if you wanted a bit more, do let me know after. We're now going to dive into what we work on quite a lot with all of our projects, and that's the building physics. And we call it the HAM principles, but it's the heat, air, moisture, movement, and how they all interact, and making a holistic approach. It can get easy sometimes to focus on one area. We want to improve the thermal performance, so we're just looking at the heat and the insulation, but we forget about moisture and air, and it can generate condensation problems. So they all kind of work together. So let's dive into the heat transfer then, and understand it a bit more. There's three main mechanisms which take place: conduction, convection, and radiation. So conduction, that's going to take place where we've got two objects in direct physical contact, and that energy is going to transfer from one to the other. That process will continue until that physical contact is broken, or if the two objects' temperatures equalizes, it's the same temperature, that process won't happen. So that's conduction. Convection is when we've got a fluid medium, so this could be air or water, or in between the two objects. And what happens here is the fluid next to the warmer surface kind of heats up, and the warmer fluid is less dense than the surrounding cooler fluid, so that arises and kind of replaces that cooling fluid in this circular motion we can see on screen. And this process will continue again until maybe that fluid medium is removed in the middle, or the temperature equalizes between the two products as well. And the final one is radiation. So this in case is going to be heat transferred by means of infrared radiation. So that's where the first object emits the radiation and the second one is going to absorb it. And the rate at which energy is transferred is going to be determined by the emissivities of the respective materials. So that's why you'll see on some materials, especially when there's an air gap in between, they'll have a low emissivity surface on their solutions to improve that performance of that design. So now we're going to take that building into context. These properties are going to interact in various ways. But for a simple example, we're going to look at a timber frame wall with insulation placed between the stud-work. The insulation, let's assume it's a mineral fibre, has a thermal conductivity of 0.03 watts per metre Kelvin. This property is going to be constant irrespective of the thickness of insulation. It's also known as K value or lambda value. I tend to use lambda value as my preference going forward as well. And it's looking at how well the sort of heat flow is across that material. But if we have, for this example, 150 mil of insulation, we can then divide it by, this thickness by its thermal conductivity, and that will give us a thermal resistance performance, or what is more commonly known as an R value. And in this example, it's going to be 4.3 meters squared Kelvin per watt. This does vary with thickness and is linear. So if we halve the thickness, we will halve the R value. The higher the R value, the better the material resists heat transfer by means of conduction. Once we kind of got the understanding then of thermal conductivities, we then work out the resistance values. We can then look at the thermal transmittance of our whole element. This could be the wall assembly, the floor, the roof, the windows, the doors, etc. And that's our U value in watts per meter squared Kelvin. So we do that with a simple calculation of the sum of all the R values and do the inverse of 1 divided by that, and that will give us our basic U value calc for our through wall construction. Now, in retrofit, old solid brick stone walls, they're going to have U values that are higher than 2, as you see on screen, 2 watts per meter squared Kelvin. If we compare that to a generic sort of modern new timber frame wall, that's going to be below 0.2 watts per meter squared Kelvin as a kind of starting base, depending where you're building. So this really highlights to me, especially if we're trying to become sort of net zero come 2050, where the greater gains are going to be with that existing building stock, improving that a lot of those projects and those buildings, those solid wall constructions, where a lot of that energy and that heat is used to keep the buildings warm and it going out and causing CO2 into the atmosphere. So this kind of really highlights that to me. That U value, however, is very simple. It doesn't tell us the full story of our design. Not all the layers in our example of the wall are continuous. The insulation of a frame wall is typically between the stud work, which is going to have a higher conductivity and is going to allow a sort of a more heat flow at those areas where the stud work is. We've then also got windows, doors, corner junctions, floor zones. All of these need to be considered for the local heat flows. This is known as cold bridging. And we account for that by adjusting the U value of our walls for the additional timber, and we apply the corrections called psi values to account for the corners and the floor junctions as well. If we can though, add a continuous layer of insulation or insulate around those structural timbers or steel work, depending on the design, those thermal bridges, then we're going to reduce those corrections and improve our overall heat loss. And we're starting to see some greater gains by doing that. So conductive heat flow is not a linear property, however, so the more we want to reduce it, the harder it's going to come. If you've got a 30mm insulation board in your design and you double it to 60mm, you don't get double the thermal improvement because it's not linear, although in your head it kind of makes sense to. So if we're looking at a generic wall build-up with 130mm insulation, well, to get to a huge greater gain of lower thermal performances, improve our energy design, we could be looking up to 500mm for 0.1 watts per square Kelvin. How do we accommodate that 500mm? How do we install it? This means that kind of just focusing on the U value can make it difficult, and detailing those thermal bridges will help improve our energy performance massively. Another way to improve energy performance, though, isn't just thermal bridges, it's also air tightness. This is where we're looking at reducing the areas through convection, heat loss. So it's looking at the unplanned air movement, that warm air leaving the building and that cold air coming in. If you've ever lived in an old cottage like myself, you'll know it as the word drafts. So we want to do detailing those drafts out of our design. We still need planned air movement into the air, so you can't. It's not like living in a plastic bag. The greater thing also about looking at air tightness, it's going to have a less impact on that wall thickness. Some materials can be less than 1mm thick. So again, improving the energy performance of our design without going to humongous thicknesses within our U value performances. So that's air tightness, but we do have to be careful because all these activities that take place in our building introduce moisture into the internal environment. So while draft older buildings might be a bit chilly to live in, the air movement is allowed to kind of easily move and escape. That moisture is allowed to escape from the building. So if that moisture cannot escape properly, it's going to lead to condensation problems where that warm moisture air comes in contact with those colder surfaces. Alongside this, you've then got the traditional building materials like lime mortars and plasters. They've got different hygrothermal properties to their modern equivalents. This means that the way they store and transfer both liquid water and water vapor is going to vary quite a bit. So we need to understand that, not just simply seal up the building. So here we've got a permeable existing wall, for example, and we're going to put a vapor type insulation onto the structure. And we see that the external wall there started to cool down, and that's going to then potentially cause us problems. Maybe external wind-driven rain could build up, moisture could build up on the outside, and freeze thaw could happen, as well as increasing our condensation risk right behind this insulation line, as it's getting too cold of a surface on the solid wall structure. It's also going to restrict internal drying, so balance the material properties. So that's something just to consider with that. So how do we avoid these issues? Well, the first step is to assess the existing fabric thoroughly, and there's a number of tools and frameworks. We're going to be looking at the PAS 2035 and PAS 2030 documents issued by the BSI, or public available specifications. Now, a lot of these principles are going to be within these documents are catered for sort of some large-scale projects, but the principles behind them are relevant to sort of anyone undergoing any retrofit type of project. Assessment of dwellings for retrofit, identification, evaluation, improvements, options, design and specification of energy efficient measures, and monitoring of the evaluation of the retrofit project is something that it goes into detail. There's principal factors that show the U value of the elements, as we discussed, also the psi values of the junctions. You then got the condensation risk to go alongside that, heat and solar gains, can that be generated as south-facing windows, etc. Ventilation rates. Now, PAS 2035 is focused on energy efficiency, so it won't go into building acoustics, but we like to put it in at this stage. In your assessment, it will help early on, including at this stage, rather than finding out it later. It can become quite expensive and difficult to detail in retrospectively. So, calculation methods, what do we have out there? U-value calc as one of the simplest methods, as we just went through those. Range of softwares out there. This is one from the BRE U-value calculator. But what's important is it conforms to relevant standards. So this is the BSEN ISO 6946. There's then also all the repeating thermal bridges and fixing air gaps. The guidance can be given on that on the BRE guidance document, the BR443, on how to adjust those. And that will give us our generic U-value of our through wall elements. From then on, we can then look at the hydrothermal assessment. So there's two methods in the BS 5250. We've got the EN 13788, which is a Glaser calc condensation risk analysis. You'll probably be very familiar with a simple design like this, where you've got your dew point temperature and your temperature gradients going through your through wall construction from January all through to December. Those two lines come in contact, that's where condensation occurs. It does miss a number of important physical phenomena, assumes the building's dry, it doesn't take into account inherent moisture, only looks from sort of one direction, from warm to cold. So if we're want to take external factors into consideration, it can go missed. And it also only looks from January through to December. Simple inputs, single direction moisture flow, no external moisture sources, and limited material properties. So the BS 5250 reference another standard, which is the EN 15026. It's a dynamic numerical simulation, and it's specified within the BS 5250 for solid wall constructions. It's a more accurate simulation that's going to allow for greater variations of environmental conditions and material properties, but also allows a bit more of a flexible approach to simulation time periods as well. So fully models that moisture flows. We can introduce that moisture within the design, taking the external weather conditions. It looks at it from the exact site location. So say we're running them for 5 years, we'll look at the previous 5 years and predict the next 5 years of weather in that area. It's more detailed simulation, a wider range of time periods. And this is important because little niggling condensation problems might not occur within that first 12 months. It might start to build up year on year, and then you'll start to notice it 5-10 years in advance, that moisture generated. So that's where this wider time period is quite critical, especially for solid wall construction. The next thing is looking at your whole energy performance of your building. So PAS recommends two. There's SAP and there's the Passive House Planning Package. Now I worked on the world's first Passive House Leisure Centre at St Sidwell's Point. Got the 2 awards up there from the UK Facade Awards. If you want to know more about that project, I'd love to talk to you about it. It was a project I worked hard on with Gale and Snowden Architects and Kier Construction. So yeah, do get in touch if you want to know more about that project. But both of them, these methods incorporate a wide range of data, looking at all the kind of aspects of the building fabric, the orientation and the systems. Gives us a real comprehensive overview of the pre and post upgrade performance. It's great because we can start to do some trade-offs, balancing that whole building performance and looking at the energy design from that point of view. PAS 2035 is also cautious of RD SAP as well. Go that a bit. Oops, sorry, skipped a bit there. We're next going to look at figure D1 in the PAS 2035 document, which is this simple matrix. Now, it looks a bit complicated from a distance, but as we dive in, you'll see it is quite simple. So we're going to look at two red interactions. So it's looking at here we've got decentralized mechanical extract ventilation and heat pumps, and they're, when you go up the matrix, they're listed as red. Now this becomes that they're kind of not appropriate to be used together. That's why they get the red color. We then have an orange color, which this example is going to highlight electric storage heater replacement and heating controls. They're going to require additional considerations to ensure they're compatible with each other and may require complementary upgrade works as well. And yellow is kind of similar to the orange, but it may just be requirements of good detailing and proper installation to make sure you achieve that specification. And then green areas such as draft proofing and solar PV, they've got no, they have little or no interactions or effects, so they present a very low risk of combination together. So it is a simple matrix that can be found in PAS 2035, like a traffic light system, to understand those upgrade measures. There's then also the inherent technical risk, which is looking at risk-based pathways from A to C. So that's categorizing the types of projects. So, for example, replacement of windows on a single house out of conservation areas is going to be sort of low risk, a low complexity. That's going to be listed towards the A, whereas maybe if we're fitting mechanical ventilation with heat recovery to listed, that's going to be graded much higher. The upgrade measures are also graded from 1 to 3. So the simple upgrades like draft proofing, that'll be down as a 1, and then some of the more complex disruptive measures like ventilation system heat pumps graded at a 3. So an easy way to understand that initial thing. And also where the qualifications are going to be recommended, the architects included, the higher up the gradings you go as well in particular. So two documents I highly recommend you look at if you're going for any retrofit or redesign refurbishment projects. We go into more detail in the presentation if you wish to know more about that as well. So finally, we just want to look at some common scenarios that pose problems in refurbishment projects. We're going to be looking at solid wall constructions, especially buildings like this where you've got that lovely external feature, not just for the building, but also sometimes the local area. I used to live in Bath, and all those buildings in Bath, the lovely Bath stone and everything. You wanted to keep it. You wanted it to be. It's a huge part of the local community. So although going external with your insulation is kind of desirable from a design point of view, detailing all those floor zone thermal bridges, with a lot of these buildings, it becomes a little bit undesirable, maybe not even practical to actually achieve. So then we look at internal insulation systems, and these have their own problems. The decoration internally, the relocation of services, sockets, all become quite a challenge, accommodating those thicknesses of insulation as well. But there are ultra thin insulation systems such as aerogel laminates that can go as low as 13 mil thick and can help to migrate that as well. Going to significantly improve the thermal performance, also keeping vapor permeability through that construction, reducing the condensation risk as well. It's quite critical. And that's the next important thing. Condensation risks is a huge thing within these solid wall construction, these retrofits. Introducing insulation, we are going to be calling it out surface, so it needs to be detailed and assessed correctly. But also one of the biggest problems with condensation in these build projects is actually those window reveals, those door openings, where it's going to be a bit more difficult to introduce insulation. A lot of the time they're left uninsulated. And that's because trying to accommodate 50, 60 mil insulation becomes difficult. We might have to take the windows out and replace them. And it's not necessarily a thermal area we're looking at, a thermal improvement we're looking at here. It is keeping that cold surface warmer. So by introducing again an ultra low insulation such as aerogel, thin materials, 10 mil blankets can negate that condensation risk with say a 3 mil magnesium board or something as well, keeping it vapor permeable. A 13 mil system in total means it's much more accommodating. Retrofitting for air tightness as well. A lot of people assume vapor tightness and air tightness as go hand in hand, play a dual function because we rely on our vapor control layers in new build design. Well, actually, vapor and air tightness are two different things. You can have membranes that are vapor permeable yet airtight. So you can apply draft strips around doors and windows. Completely replacing those doors and windows can be quite difficult. But if we go just doing the draft proofing, that can go some way to negating some of the problems. So again, introducing that vapor control layer will then be an impermeable air barrier, restrict that moisture flow, and there's potential for damage as well. So by introducing an airtight line that is vapor permeable, that will allow that being moisture neutral, allow that unrestricted drying, can still pass through, it can offer air tightness to our design. If it's self-adhesive as well, it will improve with the penetrations going through it, the air tightness results, with a layer of adhesive on the back as long as the fixings are installed correctly. And also it's going to improve the simplicity of the install, being just a peel and stick system onto your substrate. But yeah, worth considering, because a lot of people do forget about the opportunities of air tightness. It's going to also be really effective for sealing those junctions well on the design that can be tricky to get to. And you can introduce that then with a high thermal performance aerogel insulation, and you've got the best of both worlds. You've got your air tightness system, high thermal performance insulation, prevent inward drying, increase surface temperature, and reduce that cold bridging across there as well. And the final thing we're going to look at is re-roofing, a really daunting prospect for any building, particularly in traditional or historic properties. There's a variant of period details and features that makes it a little bit more less straightforward. So if we're looking at a traditional cold roof system where we rely on the eaves and the ridge for our ventilation, but we're going to upgrade and put all this insulation, a room in a roof design, we're going to kind of affect that airflow now and introduce potential problems, spots of where condensation is going to occur if there isn't the right amount of airflow through there. So how we detail that correctly is going to be difficult. And then potentially within introducing the insulation room and a roof, we need to probably look at a control layer within that design with some of the outer membrane systems. So how do we install that vapor control layer around the stud work? How do we make it sure it's continuous line, all those penetrations? It can become a little bit unreliable. How we're going to seal it well. So there are now systems such as our brand new Proctor Air, that is an air and vapor permeable membrane system that can go over the surface of the roof, and you're not then relying on your vents at the eaves and the ridge that can get blocked up. It's just a continuous membrane system, allowing the airflow through your design of any space of the roof. So hopefully less chance of condensation risk or little dead spots when around that insulation areas. And also will not require whether a VCL is required under the BBA as well. So efficient vapor transfer through that design. So that was a real speed through on our retrofit CPD. As I do mention, we don't just deliver CPDs, we also do a range of technical support and services to go alongside that. So we do the drawings, detailed markups on your design and membrane insulation systems. We do hydrothermal assessment methods, U-value calc, condensation risk, and we do a dynamic numerical simulation. We use a software called Woofy. I'd love to go into more detail if anyone wants to know about Woofy after as well. All of our products are on BIM Object Library in ISC or Revit formats. And we do toolbox talks as well. Reducing that performance gap is critical within design. So it's not just about specifying the products, it's about how we actually install them on site, making sure the contractors are familiar with them. We can come back and do site reports as well to reduce that performance gap from there on. You can find a lot on our website as well, from literature. We do sort of monthly webinars and podcasts as well, all different topics that you can find on our socials as well. So please do check our website out. And yeah, thank you for listening today.
Thank you so much, Adam. That was really good. We do have a few questions, so I hope you're ready.
Yep.
So we've got a question in from Niall. What tool software would you recommend to calculate condensation interstitial risk in a building?
So there's a couple of things. You can go on our website, and on our members area, we have a U-value calc and condensation risk software where you can do your own calculations. Our technical team can also do them, and we link in with the BRE's software for that if you're interested. So yeah, get in touch, and we're happy to demonstrate our software for you on that and where we get it from.
Great, thank you. Question in from Jay. Are the accredited details still relevant?
The accredited details for what, sorry?
That's, I can only presume they might be referring to the building regulations accredited details.
I'm not sure on that. I'll have to come back on that one. But yeah, if I can get your details, I'll come back to you on that one.
Great.
Whether they're relevant or not.
Question from Damien. Do the self-adhesive moisture air barriers self-heal if occupants want to put up heavy mirrors, etc.?
So it depends on where they're positioned, because if they're going straight onto the substrate and then we've got insulation, then say, I don't know, an internal boarding, those penetrations might not even reach that membrane. But if the occupants do penetrate it, unlike other membrane systems, that will just have sort of lateral airflow behind, there is a layer of adhesive, so there's a degree of self-sealability to those penetrations, as long as they're kind of installed directly as well. So it kind of is a bit of it depends on the position whether they can be reached, but it's a system that is typically used on the external of a lot of projects, but because it's moisture neutral, can be used internal and offer some air tightness to your solid wall construction where we've kind of ignored it in the past in the designs. So it's kind of a better approach than previous, if that makes sense.
Great, thank you. Question in from Jay, what's the best way to ventilate? Mechanical versus natural? Does new Part O allow for this?
Well, natural systems can typically get to about 10 pascals. With mechanical systems, we can go up to, I think, like 60, some systems. So you can get a lot more out of mechanical ventilation. Again, it's going to depend on the project, what we're trying to achieve, the air tightness we're going for. So if we're not on a lot of these solid wall constructions, we might not be going sort of down to the need for mechanical ventilation systems. But if we're looking at sort of air tightness below 3, we need to think about a ventilation strategy or lower than that. But yeah, it's just kind of taking an approach, and we can send you some information on the regulations for that as well.
Great. Question in from Hernando. Does the air tightness layer include a certain percentage for penetration like fixing battens, etc., or no penetration required to air tightness line?
Yeah, so again, it's going back to looking at the traditional systems of a taped on vapor control layer, which will cause obviously the condensation risk and have lateral airflow behind that. You put a penetration through, it's going to cause a hole. A fully self-adhered system to your substrate, the penetrations are going to be hopefully better sealed when they go through, but there is always a degree of risk depending on how they're installed and that. But it's a kind of an improved solution, and it won't cause a condensation risk. But it's understanding those limitations with it. And happy to come and do some demonstrations of the install of the product in any practice as well.
Thank you. A question in from Stephen. What about re-roofing thatch roofs, specific literature, etc., and so on?
Yeah, that becomes a little bit more challenging. I think there's some fire considerations with thatched roofs as well. It's not something we've been heavily involved in, but if there are any specific details, I do apologise. I'm more happy to look at that. But there tends to be certain systems for thatched roofing which we wouldn't get involved with. But we have had some of our, I think, fire-rated vapor control layers used in those designs, because I know that's quite critical. But it's not really our remit, unfortunately.
Question in from Basia. What is the cost of the aerogel insulation?
I mean, it will range on the thicknesses of the material. So as a standard, we do it in 5 and 10 mil blankets, and then we can bond layers together. Ours is an A1 fire rated. If we do bond it together, the layers together, you will lose that A1 fire performance because of the glues. So you can layer them up if you still require that, especially on like recladder buildings that we're seeing quite commonly at the moment. But it depends on the thicknesses required. It isn't a cheap system. I'll be straight up. It is an expensive solution, but it's a get out of jail card. It can be costly in certain details, but you can be looking at sometimes around £80 square meter and plus. But yeah, it's project by project we work on, and we try and value engineer it, so we can pre-cut for all the windows, for example. So instead of buying big sheets and having loads of wasted material, we'll pre-cut all the sizes for that window reveal, and then you reduce the cost massively and the wastage. So there's things we can work on to help with that.
Great, thank you. A question from Louisa. Do you have any solutions for internal wall insulation in wet rooms, bathrooms, and kitchens, etc.?
We can look at those. It's again, it all depends on what the sort of challenges were in the design. We have worked on a number of wet rooms, but it depends about what sort of kind of weight's going on the walls as well, and there needs to be other systems to protect that insulation. Now, aerogel is hydrophobic, so it will repel liquid water, unlike other insulations that will store it and damage that thermal performance. But again, it is a project that will need to be assessed, and what the boarding and the protection that offers is what would need to be looked at, and that internal lining as well.
Great. A question in from Nick. Do you find air tightness requirements run counter to radon precaution detailing?
Sorry, say that again.
Do you find air tightness requirements runs counter to radon precaution detailing?
Um, it so with radon detailing, first of all, in retrofit, detailing ground gas is very difficult because you've got your existing structure, for one. But with the radon systems, hopefully there's already one installed. They can hopefully lap onto your airtight buildings. It needs to be a continuous layer with no breaks. So it is a very similar way. Now there is some research out there that kind of all airtightness systems offers resistance to radon, but I would make sure you check the specification of the products you're using to make sure they are actually tested for it. We have a full radon range of membranes as well, that we can detail. We wouldn't recommend our airtight systems that aren't for that. It'd be our radon approved systems.
Great. Question in from Ben, asking about whether the internal wall insulation, if applied, would there be an element of ventilation included, um, etc.
So there'll be vapor permeability with the insulations. So vapor and air, it's difficult to get your head around sometimes. How can something be air and vapor permeable, or airtight and vapor permeable? Think of a football net. You kick a ball into the net, the ball won't pass through. But if we used a golf ball or a tennis ball, they would. So playing with those molecule shapes and sizes. Now, a lot of vapor permeable insulations are probably also inherently kind of air permeable as well because they're fibrous materials. So they will not require a ventilation system within that design. It's if you're looking at the membrane to prevent that air, and then what sort of levels we're going to in retrofit. It will be very hard with all systems to achieve very low performances, just inherent with the way the projects are as standard. But the insulation, as a vapor permeable system, will also be air permeable if they're fibrous.
Great. Um, Question in from Michael. Does the roof membrane that you mentioned allow for elimination of ventilation of the structure within the roof space? Or is additional ventilation required?
Yeah, so there's not additional ventilation is not required at the eaves or the ridge, or any high level ventilation. So you just have the membrane system, as simple as that. It's called Proctor air. The only time you would have to consider ventilation is if there was an impermeable outer covering, typically like fibre cements. But a lot of these, majority of projects are permeable outer coverings, so it's a permeable roof system, which means it won't need additional ventilation. But that's the only time you'd probably need to consider it.
A couple more questions. This one's quite a straightforward one. Do you offer airtightness tape application training and other relevant training?
We do indeed. So the Raptight is one of our unique airtight vapor permeable systems on the market. It comes in a 1.5 meter roll by 50, but we do pre-cut into smaller dimensions, tape details as well. And we'll go through the install, best practice, brushing your substrate off, using the rollers, etc. Because you want to get the most out of the products you specify. So we recommend it on all of our projects to get us in and go through those toolbox talks.
Great. And regarding the Building Safety Act, how has that impacted your product specification and so on?
Um, Not really kind of impacted our products as such. It just means we're pushed to do more, which is a real benefit to the design. So we're looking at system fire testing now, rather than just kind of product fire testing. We're looking at every element of the building rather than just our own elements. So it's actually driven us, and not just us, the industry further in a positive way. Don't get me wrong, a lot of the testing is quite expensive and difficult to even get booked on. It's busy in a lot of the test labs at the moment, but it's driving us in the right way. And yeah, in terms of product specifications, though, we're still innovating as well, trying to get the best fire performances. But a lot of the thing we, again, with a holistic approach, is not just improve the fire performance, but still making sure we're not getting condensation risks, and we still get the benefits of air tightness within the design where we can, water holdouts of membranes. So we're trying to innovate and tick all the boxes as best as possible, take a holistic approach, because you can solve one problem but then create another with some of the products and innovations as well. So that's a key part of us. But it's great to see not just from us but all, the whole industry getting together and really innovating with some of the changes in the Building Safety Act.
Great. And I think we've got a final question in from Basia, which is, how is aerogel insulation fixed to the substrate? Is it bonded, or if the wall is uneven, can the wall be framed out first?
Yeah, there is a range of installation options. So you can use like a kind of Instastick adhesive at not full coverage and bond it back. Probably recommend that on a very lightweight system. So we're using a 3 mil magnesium board as maximum and with a 10 mil aerogel. But if you wanted to increase that magnesium board to 6 mil, I'd recommend mechanically fixing. There are systems where you can go straight through to the substrate, but you can also batten out as well. Depending again on what's going on internally, what needs to be held up. Is it just a couple of pictures, or are we talking heavy cabinets? So all that needs to be kind of assessed. So there's a few options. Some people just mechanically fix the insulation straight through to the substrate, and then they'll put like a mesh on, ready for sort of plastering system to go on top to remove the board. So yeah, there is a range of options, and we're more than happy to look at your projects and kind of recommend accordingly and show you what other projects have done as well. But there tends to be about 4 or 5 different ways.
Great, thank you. Thank you for everyone for all your questions. Apologies if I've missed any. I've tried to go through every single one. Um, uh, if you do have any further sort of product-specific queries or would like to reach out to Proctor directly for any specific talks, then please do contact them directly. They're more than happy to come out and speak and do presentations and etc. Just whilst you're here, I just want to run through a few of our upcoming talks. So obviously, thank you so much for Adam for
Thank
doing
you.
the talk today. We have our next September event is on ESG, sustainable finance, and the built environment. That's from the Bartlett School of Sustainability. We've got Earth Center Design working with nature in October from Terra Lupa. We've got transition from 2D to 3D coming from BSBG. So that should be a really good one, especially for the people that are still are using software such as AutoCAD predominantly. We have our final talk for the year in December, on the 11th of December, coming from Moy Materials, and that'll be blue green roofs with smart control devices. So lots of interesting talks coming up. Thank you very much for attending. Again, thank you very much, Adam, for doing this with us. And we look forward to welcoming you to our future events.